National Lobster Hatchery in Padstow. It was funded by the Great Western Research Fund, the National Lobster Hatchery, with some funding from Washington Company of Fishmongers, University of Plymouth, and also the Society of Experimental Biology. So what am I going to talk to you about? I'm just going to start off by introducing the National Lobster Hatchery, really, for those of you that don't know about it. Talk about the charitable objectives of the hatchery, and also how my research fits into those charitable objectives. Then talk to you a bit about the aims of my research and the kind of overall conclusions of the research. I'm then going to talk to you about how I'm going to use this John Rose Award, or hoping to use this John Rose Award, to disseminate my research to the general public. So, the National Lobster Hatchery. It's actually the building you can see there. It's a very small place. It was opened in 2000 as a conservation project. It's actually to do with the stock enhancement of lobsters. So we rear lobsters to about 3 to 6 months old, and we release them back into the wild. And this is to kind of support the sustainable fishery of lobsters around Cornwall and the Isles of Scilly. We release about 10 to 20,000 lobsters a year, but with improvements in kind of techniques and research that we do down at the hatchery, we're aiming to kind of release around 50,000 lobsters a year. Education is the second charitable objective of the hatchery, and this is actually a very important one. This supports the conservation aspect of the hatchery. We have around 40 to 50,000 visitors a year come to the hatchery, and this supports obviously the rearing and releasing of the lobsters. The hatchery also goes to many shows and fairs just to educate the public not only about the stock enhancement programme but also about the idea of sustainably sourced seafood. We also have many visits from schools and higher education institutes. Research is the kind of third main charitable objective, and this is really where my PhD fits in. We've actually got 2 PhDs down at the hatchery at the moment, and we've done 4 master's projects and also 2 undergraduate projects. And we've also done many collaborative projects with organisations such as DEFRA actually, and European Social Fund, and we've just started one with the European 7 Framework objective. So where does my PhD fit in? This is what I was thinking when I started to write the funding proposal for the PhD, and it was basically the idea of improving the growth, survival, and also the health of the lobsters, so we could release a larger number of healthier lobsters back into the world, so they've got more chance of surviving once we release them. At the bottom, that's just the title of my PhD, so it's just developing the use of biotics in aspects of the brood, larval, and juvenile European lobster culture. So you ask, what are biotics? These are actually substances that they're used as preventative measures. So rather than using things such as antibiotics and such like, we use a measure that will improve the health of the animal and therefore success in culture. There's 2 main types of biotic supplements, and these are prebiotics and probiotics. The prebiotics are kind of non-living, non-digestible plant extracts, and these are often derived from yeasts and are commonly carbohydrates. These will actually reduce the number of pathogenic or so-called bad bacteria in the gut of the animal. And they do this, one of the prebiotics that I used in my PhD called mannose oligosaccharide, and it actually basically binds itself to the mucosal lining of the gut and acts as an alternative binding site for those pathogenic microbes. Once they've attached to the mannose receptors, the mannose oligosaccharide flushes itself from the system, removing the bad bacteria with it. So that's how it removes the bacteria. Probiotics, on the other hand, this is more like the human kind of yakult, to put it into perspective, but I'm not feeding lobsters yakult. It's live bacteria that benefits the gut fauna by outcompeting the bad bacteria, and it'll do this for things such as nutrient and space. So what have these shown to do? They've shown to improve food conversion in animals, and they do this by allowing the development of the mucosal folds within the gut these are the villi and microvilli, I'm sure most of you have heard of them. Well, once the development of these folds has been improved, there's an increased surface area, and that allows for the absorption of more nutrients and therefore better food conversion and increased growth rates. They've also shown to reduce disease susceptibilities, and they do this by enhancing the immune system of the animal, and therefore they've shown increases in survival.